Having recently completed the videos for construction of the version 1.6 BusRaider, I'm now going to go through the procedure for building version 1.7, which is a recent upgrade which adds debugging support. So without further ado, let's get started. I think I've assembled the whole set of components here, but I may need to find things as we go along. Just looking at the other side of the board, we'll do what we did last time, which is to put in place the lower height components first. That just makes it easier to keep the components in place while we're soldering them. So I'll start with things like this 74LVC07 and just get that in place. As before, I'm going to put in place one of the legs of the component to hold the chip in place while I go ahead and solder the others. So starting off with the leg at the bottom right hand corner and just soldering that into place, and then we'll go ahead and put solder the rest of the leads of that component, making sure that we've got it the right way round. The bar on this component is at the left hand end, so again I'm using a fairly large tipped soldering iron, partly as before just to demonstrate that it is possible to do that, partly because I just quite like this soldering iron. I can use the same soldering iron for pretty much all of a board like this, and potentially quite a lot of other larger connectors as well. It has quite a lot of heat capacity. Sometimes it bridges across two tracks, but if you're fairly careful, you can make sure that you only leave the solder where you want it to be. So there's a set of connections there. They aren't absolutely perfect, but they are absolutely fine. So now we'll just carry on with the other low-lying components. It's probably a good idea at this stage, I guess, to get this little capacitor in place. That's definitely one of the smallest components that we'll need to deal with. I'm just looking around to see if I can find some tweezers, which don't seem to be here, so I'll break for a moment. Okay, so putting in place this small capacitor, so this needs to go up here, and again I will, so the position for it is actually for a rather larger component, but I think we can manage to make that work. This just needs to be, actually this is just a 3 volt power rail, so any capacitor with at least that level of voltage rating would be okay. So that's that one in place, and then I think we'll continue with this 3 volt regulator, 3 volt 3 regulator. So similar idea, we'll do one pin, maybe we'll do this one at the top, slide the component into the place that we want it. Oops, lost it. So yeah, slide the component to where we want it to be, make sure it's flat to the board, wiggle there. Right, I think that'll do. And then we can come back to that connection and make sure that it's properly tinned. So I'll just do that one. Okay, so that's that done. What else is there that's quite low lying? Well, I've changed the resistors on this board to be axial from surface mount, so these are sort of old-fashioned resistors, if you like. There are two 470 ohm resistors here and here, and this is a 470 ohm resistor that I have in my hand, blue, purple, brown, in the 5% range. So this is actually, the board's actually designed for 1/8 watt resistors, and this is a 1/4 watt resistor. So as you can see, it doesn't quite fit, but with a bit of judicious bending of the legs into a sharp right angle like that, very close to the body, which can be done by pressing your finger against the resistor quite firmly to make it as tight as possible, the legs as tight as possible to the body, then I think we can get these to fit okay. They're not going to be perfect, but they'll be workable. These are a lot easier to get hold of than 1/8 watt resistors, I've found after designing the board. So I probably should have designed it for 1/4 watt ones, but because they're not really very significantly bigger, but it's slightly annoying having to try and force them into place like this. I'll try and source some 1/8 watt ones in future. But anyway, this kind of does the trick, so you can probably see those going in place there. So we'll get those soldered onto the back. As before, I've bent the legs out sideways to hold the component in place just while I solder it. And as before, I'll mention that it's best not to bend them too far, otherwise it can be very hard getting the component out if you ever need to do that. So a pair of side cutters like these are useful. The cutting edge is angled towards the bottom, which makes it much easier to get a sharp cut onto a lead that's actually quite close to the board. So one more resistor, the 10k resistor somewhere, there it is there. So we'll put that one in place in the same way, again bending the leads tight down to the body of the resistor, and then I'll put that in so that it reads downwards. I tend to try and put resistors in so that they either read left to right or bottom to top in terms of the resistor color code. So that one reads brown, black, orange, which is 10k, and if you do it so that they all read in the same direction, then it tends to look a bit neater, and there's not really enough resistors on this board to make a huge difference to that, but I always find it's nice to have a neat end result, so that would be my recommendation. Again, just chop those leads off, move those out of the way. Right, and then so now we're on to the next level of components. This is actually a low component, but actually goes on the reverse side of the board. That's an SD card holder. That's a new addition on this PCB revision as well, but we'll come to that later once we start doing the reverse side of the board. There's a diode here, so we might as well put that in place now. Similar procedure, if I can work out where it goes. Can't just see it now, I think there it is there. So the effective stripe that you can see here goes with the black line on the resistor itself, the resistor body. So we'll put that one in place. As I recall, I added that resistor just as protection for the 3-volt circuitry on the board. just in case you inadvertently connected a 5-volt version of the FTDI cable. That's the kind of serial cable that the board uses to program the SP32 and also to communicate potentially with a PC, either directly from the Z80 or from the SP32. So I think now maybe is a good time to think about putting the ESP32 in place. I think that's probably the next lowest lying of the components that I can see in front of me. So we'll just put that in the right kind of place, and then we'll get one of its pins soldered. I think I'll go for this one up here at one corner. So now I've actually done a few of these recently, and I've noticed that quite often I struggle to get the solder accurately onto each of the pads. So after this process of getting the chip lined up, which I think I've done to my satisfaction there, so after this process, I'm not sure if you can see that well enough there. Don't know how. I think I've done fairly well there in getting it aligned on that side. And again, it's moving actually. That's not so clever. Don't know how that happened. Okay, I'm going to move again. Okay, so yeah, I think it's fairly well lined up there, and there, and there. So now we'll solder the rest of those in place. So I was just starting to say I've soldered a few of these in place, and I found it quite difficult to get the solder just to stay onto the legs that I'm really looking for, and to get a kind of even degree of solder in place. So what I've started doing is actually what I'm just doing now, which is being a bit heavy-handed with the solder, allowing it to go over many pins. So you can probably see that there's a few bridges there. There's at least 2 or possibly 3. Yeah, there are 3 solder bridges, or 4 actually, because that's a 3-way bridge there. And now I could either just try and pull some solder off like this, which doesn't tend to work very well, or I could actually use some solder wick, which is this sort of stuff. It's important to get wick that has a flux in it, like this multi-core one. You can get cheap wicks, often you get them from China, I've found, and they don't have any flux in them, and they're almost they're impossible to use without adding flux, which is quite a rigmarole. So I definitely recommend ones with flux. And then you just put the wick on, put the soldering iron on top of the wick, and then just go along, work along the pins, and it will just suck up the solder, the excess solder. So you can see in here it's filled the wick with some solder, and now we have, actually we still have a bridge, so I'll have to redo that. But if you leave it on for a bit longer than I did then, so we'll leave it on a bit longer and let it soak up a bit more, then you get a result which kind of closely resembles a flow soldered result. So it's actually sucked away a lot of the extra solder, and you just get a very clean end result. The only thing that you do get in addition is a bit of flux on the PCB around here. Now that's not a problem, but you can also just clean that off with some generally isopropyl alcohol or some kind of solvent that will dissolve the flux. So I'm going to do the same thing again on this side. It does make the whole thing a lot quicker to do because you don't have to be anything like so careful about the process of soldering, as long as you've managed to make sure that each pin has got some solder on it, and then just start this process of cleaning it up. You can just drag the wick down as I'm doing there, and it kind of reveals very clean pins. Didn't do the very end one. Very clean pins there, and makes a really nice job. Now the only problem is I've noticed that this third pin hasn't actually got any solder on it anymore. I think maybe I haven't pushed the ESP32 down to the PCB quite firmly enough, so there was probably a gap there, and that was enough to mean that when I used the wick it sucked the solder out of that gap. Yeah, I think you can possibly see on this side there's a little bit of a gap at this end where there isn't a gap at this end, so that's, well, there's less of a gap anyway, so that's not ideal. It's probably a bit late for me to try and fix that problem, unfortunately. Now one thing I haven't done on this one, which I did on the previous one, was to put I'm just holding it down slightly just to push it down towards the board. I'm not sure if that's really going to work, but that's what I've done. I don't know if you remember, if you watched the previous video, you might have noticed that I put some paste from a computer, like a PC heatsink, so some heatsink compound onto the pad in the center of the ESP32. I haven't done that on this one. I've generally found that they don't run too hot, ESP32s, so I'm not sure how necessary that cooling pad actually is. But if you do have available heatsink compound, then I can't see any harm in putting a small amount of it onto the central pad. Just try and make sure it doesn't flow outwards and cause any problems with the connections to around the rest of the chip. So just visually inspecting now, it looks to me as though all of those connections are fine. I can't see any bridges. This side looks fine, and this one does too. So that's completed that component. I think now we will start to put the chips in place. They're probably the next thing to do. So there's a few extra chips over and above the version 1.6 design. One chip was added to counteract a problem to do with the timing of the bus. So getting previously the Raspberry Pi had to kind of time the end of a read process, a process where the Z80 or the processor, the target processor, was reading from memory, and I've put that chip in the wrong way around, so you want to avoid that, definitely. Let's try and reverse that. So I've added a part of a 7474, which is a flip-flop chip. I've added that to allow the Pi not to have to worry about timing the end of the read process. And then there's also a couple of extra chips, or a couple of extra gates and an extra flip-flop used, which are intended to help with the debugging functionality, which is what I've added to the board. So the idea there is that you will be able to run a program directly from the Raspberry Pi's memory, so the Z80 would not need any RAM directly wired to its bus, and that also could allow the Raspberry Pi to feed debugging instructions to the Z80 in place of regular instructions. So it should become possible to do breakpoints and other kind of testing on the Z80 without any additional hardware. And that software hasn't been written as yet though, so I've still got a bit of work to do there, but the hardware is what we're concentrating on right now. So again, last time I think I explained that you can roll forwards these chips. They start off with their pins splayed outwards quite heavily, and so it's a good idea to try and get them closer together so that you can then insert them into the board more readily. They're designed for insertion by a machine rather than a human, so it's quite hard to get them in if you don't bend the pins rather. I'm still struggling with that one, so let's go a bit further. So, okay, that's about it for that one. Get that one in place. Okay, so we'll continue. That pad actually has bridged, sorry, I'm not sure you can see, that pad's actually bridged onto this mounting point for the Raspberry Pi. That's not a problem. The Raspberry Pi mounting pads don't actually connect to anything, so it doesn't really matter that that pin is touching. Okay, so I'm just going to try and go through these as quickly as reasonably possible, and then we'll just keep moving on to the extra chips. So I'll try and speed up a little bit. Always good to make sure that you check that you've put the chip in the right way around before you start soldering it. It's quite annoying having to take them out. Sometimes, I think I talked about this in the previous video, but I mean it's often a good idea to just chop, if you're not going to use the socket for putting the chips into an IC socket, and I don't tend to bother with them unless I'm doing a first prototype, because they just add another level of uncertainty to whether the connections are actually properly made or not. So what I would recommend, if you do have a chip that you put in the wrong way around, it's probably easier just to chop the leads off at the base and then just pull the pins out individually, rather than trying to get the chip out of the board again. You often end up damaging the board when you do that, and that ends up costing more than most of these chips, which are generally just a few pence. I mean, some of them are a bit more expensive, but most logic chips are pretty cheap, so it's not really worth risking spoiling the board for a logic chip. So just check that I did put that in the right way around. Yeah. I've chosen to put the labeling on this board with the labels written kind of in the opposite way up that they would be on a chip, in the orientation that the chips are, and that's just to keep all the writing on the board the same way up. So if you look at, say, this is 74, it's the wrong one, 7402 HCT02, the writing you can see is the right way up now, but it's orientated that way when it's inserted in the board. So my writing on the board is actually upside down compared to the writing on the chip, just to confuse you. So I'm just applying a bit of pressure with my thumb there to the pin, just so it doesn't fall out as I turn the board over. I'm sure you can develop your own techniques for doing these things, but that's one that I've just generally found helpful. Just avoids the chip falling out before you've even got a chance to solder it in place. There we go, I'm going well with this. So 138, which was the one I just picked up before. No, not that one. No, not that one. That one there. Okay. This one seems to have pins straight on one side and splayed out on the other, which is unusual, but there we are. So then that's now starting to take shape. We're probably about halfway through the chips that need to be put on here. Each iteration of this board has got more chips on it than the previous one, it seems. I started out with this board intending to use nothing other than just old-fashioned dual inline packaged 74 series chips, even though there is there's obviously an ESP32 on there and there's a Raspberry Pi that sits over the top, but realities of trying to fit everything on the board and the decision to try and not to use discrete field effect transistors that I was using previously caused me to decide to use this little 74LVC07, which actually is quite a nice way to effectively get 6 open drain field effect transistors in one package. So that was it's worked out quite well, I think. It's not actually too difficult to solder in place. So maybe if I do end up with another version of this board, I may just end up finally going for all surface mount components. Be a bit more challenging to solder perhaps, but I think you're probably up to it. So it's always good to keep experimenting with these things and improving your skills. So we'll go for the one that I've missed out there, 74. Oh no, that's a HC590. So this one is the 74 HCT74. So I'll put that one in place. I haven't quite bent that one enough. Try again. Okay, that's alright now. So you can see by making sure that I didn't put anything that was higher than these dual inline packages on the board before I put them in place, I've made my life much easier in terms of soldering them, because I can just know that if I can hold it in place while I turn the board over, then it'll be held there by the board itself, and that's makes it quite convenient to build what otherwise will be quite fiddly, I think, trying to get all of these components soldered in if you put them all in at the same time, or if you tried to put them in place after you'd put something that was taller than them in place. It would definitely make it a lot harder to construct. This one doesn't seem to want to bend quite as much as the other ones did. I suppose it's got a few more pins, so it's offering up a bit more resistance. So these are the longest chips that I've soldered in, the 474 LVC245s. Those are the chips that are used to level shift the voltage on the Z80 bus, which is 5-volt logic levels, to the levels used by the Raspberry Pi, which are 3-volt. So, and it also provides, they are also bidirectional, and so they can basically take inputs from either side. So they have 8 inputs, or 8 A lines and 8 B lines, and the A's and B's can be either inputs or outputs depending on the level of another pin. So that basically means that you can look at something like a data bus, which is a bidirectional bus, and level shift all the lines on the data bus in one go with one of those chips, all of the 8 lines on an 8-bit data bus anyway. And then the other 3 of the chips, one of them is used for the control bus, and then 2 of them are used for the address bus, which are not, well, the address bus isn't bidirectional, so that functionality of the chip isn't used. But the other ability of these chips is that they have tri-state outputs, and that basically means that the outputs can be turned off. So when they're operating in a particular direction, you can then have the output for that direction turned off, which means that you can, for instance, in the situation where the BusRaider wants to take control of the address bus, the Z80's address bus, it can request that control using the bus request line, and then when it takes control, it can, up to the point that it takes control, it has the outputs, its outputs of its address drivers tri-stated, so they don't interfere with the Z80's own address bus driving. And then when it gets acknowledged that the request for the bus has been given, then the outputs of the 74 LVC245 that drives the address bus can be put into driving mode, so non-tri-state mode, and then that allows the Raspberry Pi to put an address onto the address bus. And that's the means by which the Raspberry Pi can get access to the Z80's memory and read and write the memory of the Z80. Okay, so continue to make a bit of progress. I realise I've put that chip in upside down. Very foolish of me. Didn't properly check while I was chatting away there, so I'm going to have to take that one out and put a different one in. I'll just show you how I would do that. So I'm not going to bother trying to desolder all of those pins. I'm just going to cut them off relatively close to the board, or it doesn't really matter where I cut them off. So I'll cut all these. And then I will do this side. I could have pretended that I'd put that in upside down on purpose since I talked about this process, but I didn't. So there we are, we've got the chip removed now, and now it's just a matter of getting rid of all of those extra bits of metal. So you can either do that with a solder sucker. It's probably the easiest way if you can get it to work for you. It's not working for me at the moment. There we go, that's one of them clear. No, it isn't. It's still in there. This does tend to be quite fiddly, and normally I resort to just tapping the board or using solder wick or something similar. Right, that one's come out. So still a bit of a time-consuming process to get this to get all these removed, but it's a lot easier than the alternative, which is basically to try and heat all of the pins on the chip at the same time, and then try to get the chip out in one go and intact, so that you can put it back in place the other way around. You could try doing multiple of these at a time. There's no reason that you can't do two next to each other if you can get the solder to melt on both of them at the same time, if you have an iron that's big enough, and then see if you can get two out at the same time. That's perfectly okay too. I could try just doing it without. Oh yeah, there we go. So those came out without me really having to use the solder sucker, so maybe we'll try that now on this side. Got one of them out. That's the other one. So definitely you don't want to be doing this on an important piece of furniture or anything like that. You need something to protect the work surface that you're on, because you will make a mess of it if you do this kind of thing. Is that one still there? No. Okay, so I've got that pretty clean now. I might need to clean up those holes a bit, and I'll just get another chip to replace that one. Okay, so I've got a replacement chip now. That's the dead one, and there's a replacement. So just do the same thing again, roll the legs. And I'll try and get it in the right way around this time. So that way, a bit more bending. Okay, right, that's correct. A bit of this mess. Right, and off we go again. Soldering these in place. It doesn't seem to have done any damage to the board, which is good. Can't see anything anyway. So that's that last chip done. Right, so what's left to do? Well, we have this component. So this is the resistor array, and that goes in here. We need to get that the right way around as well, so you can see the writing on it, I think. and when the writing's this way round, there's a little mark at this end, and that is the one that goes on this square pad here. So we'll put that way round like that. It's just a little bit higher than these chips, so hopefully we should be able to keep that in place while we solder it. Start at this end. Just make sure that it's more or less vertical, doesn't really matter, but it's always good to try and keep it neat. Not sure you can really see that, but there we are. It's now more or less vertical. And then I'll just solder these. Then I think we move on to, possibly might make sense to move on to the connectors next. There are a few other components. Actually, the switches might be a logical thing to do. Oh no, they can be done quite late on, sorry, because they're surface mount to the other side, so to the top side, so that's fine. The through-hole components that we have left, these ones, these can sort of have their leads bent so they hold in place. This goes on the bottom side. This is, I'll come on to that in a moment, but these are basically for the Raspberry Pi, and then we have this strip of pins which we need to break up to populate a variety of different header sockets, all these ones here. So we'll do that now. So I'm just going to count off 6 for this one, so 6 pins like that, and then you just hold your nail into the groove or something in the groove, and then just apply a bit of pressure. It just breaks at that point, and that's going to go in there like that. Again, I'm just holding it with my thumb. It's quite nice to get these nice and vertical, so generally I do 1 pin and then I check how vertical they are, and they're fully seated. That actually looks pretty good as it turns out, but I think I might just make sure that it's, yeah, so I'm pushing down, making sure it's held firmly against the board, and then we'll just do the other pins on there. So that's the connector for the FTDI serial. Then we've got these here, so there's 2 lots of 3 pins here. So I'll break off 2 lots of 3 like that. Put those into there. They just about fit with the resistors in that position. I need a bit of, oops, just going to press it down with the flat of these side cutters, just to make it sit in place. It's a bit of a wonky angle, mind you, so I'm just going to force them into a vertical position. It's just shunted the resistors a little bit, but that'll be fine. One of them's fallen out. Can't seem to get that in place. There we are. So let's try and stop that falling out again. Again, I'm just going to solder 1 pin to start off with, and then try and make sure you don't just touch the pin that you've just soldered. Okay, that looks okay, I think. I'm completely happy with the way that one's seated, but I think it's just about okay. I'm going to have to make sure we don't bridge the track to these resistors, which are pretty close. I think we've got away with it there. Right, and then we've got, I think that's 9 or 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So just hold it against there and get the right position. And break that one off. And then we want another one the same. So we'll break that one off. So we've got 2 9s there. Strange problems getting these into place. And there we go. Right, so that's that. That one and that one. And then again, we'll just make sure that they're vertical. Again, they look pretty good. I'm just going to touch that one. It just seems like it might be possible to make it slightly better, but maybe not. There we are. And then, so there's a 1 pin, there's a space for a 1 pin header here. It's optional whether you put that one in place. It's really just a ground pin for testing. Often quite useful to have something like that to connect an oscilloscope probe or a logic analyzer probe to when you're probing around a board if you're trying to debug something. So that's why it's there. It's not actually a functional requirement to have that one in place. So there we go, that's that set of headers. There's also a set of headers along here. Again, these aren't required functionally, these are just extension headers, so I'll leave those. And a lot of the other holes that you can see in the board that remain around here and up here and down here, these are all just for extra extension components. I have remembered though that there's 2 more of these headers to put in place here and here. So one of these is for, broke it in the wrong place, that's a 3. I'll keep that for next time. So that's a 2 and a 2. So yeah, one of these 2 says page and one says clock. So the page is new in this version of the board, and the idea of that is that if you were using a paged memory system, and some of the Z80 designs do that, so they have a chip which is used to control whether memory or ROM is in a particular address space in the Z80's address bus, on the address bus or address space. Then this pin can be used, this page connection can be used to disable those chips when this board is grabbing hold of the bus and using and writing to the bus. So it's just an additional convenience. So then we're going to put this one in place. Oh, actually, maybe, yeah, I think maybe we will put this in place next. So that's the position for the Raspberry Pi. So I'll get that one in there. Doesn't matter which way around you put this. This one does have quite long pins though, so I'm going to have to chop them off, I think. Some of these connectors have quite short pins, which is quite convenient when you're soldering them into a board like this. This has sort of medium length pins, I'd say, so they're not really long, so they could be used to piggyback another board on another connector on the other side, but they're long enough that they might interfere with something when this board is plugged into an RC2014 bus, so we'll probably have to make them a bit shorter. You can see they're a bit longer than everything else on the board there. Okay, so I've been experimenting as well. I say I've been experimenting. I'll be looking at the feasibility of using a different Raspberry Pi with this board. The Raspberry Pi Zero is the least powerful of the Raspberry Pi family, and some of the functionality of this board requires quite a lot of work from the Raspberry Pi, so graphics updates and so on. So I've been looking at faster, and also actually some of the debugging functionality. So I've been looking at faster Raspberry Pi family members, and the A looks quite an interesting one, so I've got one of those now, and I'm going to have a go at trying it out in this board once I've tested everything else. Now I'm also going to use a cut down piece of this socket strip, just to show you how to do this. It's not quite as easy as breaking the header strip, but with a pair of cutters like this, if you sort of trim the ends that you may have previously left a bit messy, so you can trim the ends off like this, get it reasonably neat, and then count out. In this case we just need 2 pins twice, so I'm going to, so I've got those 2 pins there, so if I now go into the position of the third socket and I just bite into it with my cutters, and then just move down a little, do it again, and basically just cut where this third pin is. So that flew off, which you may want to try and avoid, but fortunately it bounced back at me. So then I'll just do a bit of a tidying up job on this end, just to neaten it up, and there is a workable, not the neatest, but a workable 2-pin socket, and we can just drop that one into there, and then I'll do the same thing again, neaten this end up. Might want to just make sure you've got some safety glasses on or whatever while you're doing this, as things can fly off. That actually went across the room, so I'll retrieve it. Okay, back again. So again, just neatening up the ends of this. And again, there we are. It's not the neatest, but it'll do as long as it fits in place. So these 2 extra connectors, these only work with the Raspberry Pi Zero, I think. I don't think I've checked with the A, but I don't think the A has the necessary additional pins around its expansion connector, but one of these is for reset and the other one is a composite output video signal, which I don't actually use on this board, but the pins are there anyway. I've just used that header, that extra bit of 3-pin header, just to hold these in place while I solder them, so that they're going to stay there. And then And then we'll just solder these. And then I think we're just down to a few switches, LED, the SD card. Get these bits out of the way, and these two FETs. Might as well, I think it's probably time to put these in now. So one of them goes there. Just need to get them orientated the same way as the little marking on the board. Hold it in place with your finger, and then just bend the legs out slightly so that they just get held in place while you solder them, because these are now not the tallest things on the board anymore. So we'll just do them at a time. These have got very small pads on the bottom, so you have to be a little bit careful not to bridge across. And I'll do a bit of visual inspection of this just to make sure I haven't. It goes out of focus on the camera, unfortunately, but I think you can see there that they're not bridged. So that's that one. Get that done. Next one is, it's interesting. So there are actually 3 positions for these. So, oh yeah, that would be right. I do recall now adding one. So these are all 3 the same BS170 field effect transistors. So I'll have to go and get another one of those. Just to bridge that, I think I've got that clean again. Okay, so that's that one. See how long it takes me to find one of those. Not too long, hopefully. So, let's check it is what it says in it, what I think it is. Can you see that on the camera? Probably not, but I think it does say BS170. So that one goes in. Same deal. And then that's all good. So it's always a good idea to take your time and really check. Visual inspection is a very important part of electronics construction. I'm just wondering about that one there. So I'll get some magnifying equipment, have a proper look. I think it's okay. I'll just nibble a bit more off there. Right, so that's that one. And then the LED. Now, I think I struggled with this last time because the marking's not very clear, but I think the bar side is this side. That will be the cathode. Unfortunately, this particular marking on the board is pretty unclear, but I'm pretty confident that is the case. So that would mean that the longer lead, an LED generally has a longer and a shorter. The longer one's the anode, so that one's going to go that way round into there. So drop that in, bend the leads out as before. Just going to do one side and then push it into place. Not sure if that felt right. Not quite right. Still not quite right. probably right now. Do that side, and redo this side. That's that one. Right, what else is to do? So we've got this connector at the bottom, the 90-degree angled connector, and we have these 3 switches, and we have the SD card socket. So I'm going to do the switches first. I'll do this one that's labeled demo. In fact, what I'm going to do is I'm going to put a bit of solder on each of these first. Then I'm going to put these in place one by one. That's that one. Do this one next. It's a little bit more awkward. That one. And that one. Not perfectly aligned, but not bad. I think that's about right. And now we'll just do the end of this one first, so that this one doesn't move. The end of this one, for the same reason. Then we'll do the middle of these two, and then we'll do, which actually are common together, so that's just one big pad. And then we'll do that one. Right, so we're almost there. So I think we'll do the right angle connector now. So here we go. So there's a little bit of a trick to this. The RC2014 bus isn't a full row of 40 pins twice. So on one side it's a full row of 40 pins, as you can see there. Excuse me. On the other side, I guess it's about 26 or 28 or whatever that number is. So we need to, what that means is we need to extract some of these pins which would otherwise conflict with where these chips are. And the way to do that, the simplest way that I've found to do that, following I think a video from Spencer who designed the RC2014 or somebody similar, is to use one of the holes in the board and then just pull the pins out. So you have to be sure which pin you're trying to pull out. But if we put this on here, you can see that we want to pull out these upper row of pins here. So we'll take this way round, and we'll put one of these into a hole in the board like that, so it's kind of holding it in place. And then we'll use something, perhaps these, to just extract these pins one by one. So they're not generally very difficult to remove. Just needs a sort of little bit of pressure, a little bit of pull to remove them, to try and make sure we don't break the connector in the process. Some of them are a bit easier than others, so you need to make sure you don't pull out too many, but I think there's quite a few more to do. So I'll try and put this a bit more firmly into here. If that will work. Yeah, it looks as though it will. So now I can remove that one, that one, that one, and that one. Oops. That one, that one, that one. Alright, now how many have we done? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And we need to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16 by the look of it. So it looks as though we've got 3 more to do, so I'll do 2 more and then I'll count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, so 1 more. Right, so that should be it. So we've now got the connector with a few pins removed. And if I've managed to count correctly, then that should fit exactly in place there, which looks good. So we just make sure that's fully seated in place, and then just go down all of these pins and just make sure that we've soldered all of these. So as I said in the previous videos, I'm not using a fan to blow away the flux that's burning off as I solder. I would normally would, and I strongly recommend that you do. I'm only doing it because it makes a noise on the video recording that means it doesn't come out very clearly. But for the sake of your lungs, I would strongly recommend that you do that. Over the years I've developed a technique for keeping my head to one side, and when I'm not talking I tend to blow the smoke away. That was the technique I used when I was much younger and didn't have a fan. So I wouldn't necessarily recommend it. A PC fan is only £1 or £2, and sticking it onto some otherwise unused voltage source like a 12 volt for a PC fan, or if you have a 5 volt fan, then just a USB kind of power supply that you can just wire up to give you 5 volts is an easy way to very cheaply get yourself a fan. That means you can just blow all this nasty smoke away. So I'd strongly recommend doing that. Okay, so we're almost there. Just a few more to do. And then the final piece is just soldering the SD card connector in place. It's very much an optional component, and I haven't actually put in place any software really properly to use it yet, but the idea is that you would be able to store on it files that you wanted to subsequently upload to your Z80. So you could put your archive of Z80 software on there, and then just have the combination of the ESP32 and the Raspberry Pi send your game or whatever software it is that you want on the Z80 up to the Z80 just when you need it. So again, solder 1 pin in place. So that's the only thing I've got soldered on that connector at the moment. Make sure everything's fully aligned, and then just go along and solder the other ones. You could possibly use the technique I used on the ESP32 here, of soldering all of these pins and then using the solder wick to just neaten it up. That would work perfectly well with this as well, I should think. It's not working. Okay, and then you need to stop this from just breaking off the board. You need to make sure that these corner points are soldered. So I think you can probably just see there that those are the points that gives strength to the mounting of the SD card socket onto the board. And that is pretty much it. That's the completed board.